All right, today we're doing an example of a max and min question, and I've typed this 3 times now, and third time's a jam. Look, this is a question that's appeared in some textbook that I've seen before, and it's found its way or variation of it in the past HSC. So it's basically comprised of a French window where the bottom half is a rectangle and the top half is a semicircle. And they told you that the material needed for the outside of that rectangle is 20 meters. That's what you're given. And in fact, the perimeter of this is 20 meters. And you're asked to find 2 things. Question 1, you find the dimensions so that the area is a maximum. Question 2, they ask you to find the maximum area. So when you do maximum minima, there are steps to follow. So step number 1 is you draw a diagram. Step number 2, you label the dimensions of that diagram. Step number 3, you find the expression that you're looking for that is a max or min, in this case, the area. Step 4, you express this expression that you found in there in terms of 1 variable and 1 variable alone, so that you can differentiate it, which is step 5, you differentiate it. And then step 6, you differentiate again. You differentiate it because you want to find the turning point. So you want to differentiate and find the turning point. You differentiate again to determine the nature. Of the turning point. And step number 8 is you answer the question. And the question is different. Depends on whether they ask for the dimensions or ask for the area. The answers are different. Most of the time, steps 1 and 2 are given to you. But in this case, so the question is normally a whole bunch of words, and they have to draw a diagram. In there, you see the diagram is normally drawn for you, and sometimes it's even labeled for you as well. So let me label this as X. Let me label this as Y. That means the diameter of the semicircle must also be X. Let's say this is the arc length L. That's going to be pi r. And the diameter here is X in this case. So the radius here is X on 2. So the arc length is pi X on 2. So let me then label this as area 1 and this is area 2. And so I'm up to step 3 now. Find the expression of the area. So area 1 first is just simply X times Y. Area 2 is the area of semicircle, which is pi r squared on 2. And as r is X on 2, when you expand that, you get pi X squared on 8. So the whole area is just area 1 plus area 2, which is xy plus pi x squared on 8. And as you can see, this is in terms of 2 variables, x and y. So you have to change it into 1 variable. How? Well, you have to use the information given to you. You're given that the perimeter is 20 meters. And the perimeter consists of x plus a y plus another y. So this side's also y. So that's 2y plus L, the arc length. So that means 20 then equals x plus 2y plus the arc length is L r pi theta, pi r rather, sorry. So that's pi x on 2. You want to get rid of the y. So divide both sides by 2, you get 10 equals x on 2 plus y plus pi x on 4. You make y the subject, shoving everything over the other side, you get 10 minus x on 2 minus pi x on 4. And let's call this 1. And let's call this 2. So when you substitute 1 into 2, then push up a bit so you can see. Then you get your area then is x times the y, which is 10 minus x on 2 minus pi x on 4 plus pi x squared on 8. And if you expand that, what you get then, let me continue on the next page, is that you get 10x minus x squared on 2 minus pi x squared on 4 plus pi x squared on 8. And if you do the algebra correctly, then you end up with minus pi x squared on 8. So there's your expression for the area. Now, so you're up to step number 4 now. You've done step number 4, which is find the expression in terms of one variable. Now you got to differentiate that expression. So you go, all right, dA dx then is equal to 10 minus x minus pi x on 4 when you differentiate this. And if you check out the x as a common thing, that equals 0. So to find the turning point, you've got to equate that to 0 when x is equal to 10 divided by 1 plus pi on 4. And if you're good at algebra again, you get 40 plus pi on 4 when you rationalize the denominator and so on and so forth. All right, so when x is equal to 40 on 4 plus pi, y then is equal to the expression you found before, don't forget, and I'll just put it up here so you can see. So y was 10 minus x on 2 minus pi x on 4. So you just substitute x into that. And you end up with 10 minus 20 over 4 plus pi minus 10 pi over 4 plus pi. And when you do your one-half algebra of doing the denominator stuff, common denominator that is, you end up with y then equals to 20 over 4 plus pi. Now, you have to differentiate again, by the way. You haven't finished yet. You just found x and y. So you got to differentiate again. Why you differentiate again? Well, you differentiate again to see whether it's a maximum minimum. So you go d squared a dx squared is equal to minus 1 minus pi on 4. And that's negative. So the theory is if it's negative, therefore the area is maximum because the second derivative is negative when x equals 40 on 4 plus pi, when y equals to 20 over 4 plus pi. And you've answered the first question. First question says find the dimensions of the area is max. There is a question there. Find the dimensions of the area is max. Well, the dimensions are when x is equal to 40 over 4 plus pi and y equals to 20 over 4 plus pi. That's 40, by the way, like that. Then the area is max. So that's the first part. You haven't answered the second part yet. Second part says find the maximum area. All right, so this is where your algebra needs to be okay. My algebra was bad before. So just to remind you, the area is here. So that's 10x minus x squared on 2 minus pi x squared on 4. Now, if you take the x out, in fact, if you take the x on 4 out, then you get 40 here, minus on 4, so that's going to be x, and then there's a 2 here, and then minus pi x. That's what you get when you do that. And when you take out a further x out of this lot, so you get, so that's x squared on 8. I made a mistake there, sorry. So when you take the 8 out, in fact, then you get 80 here, and then you get 4 here, and you get that there. So when you take that there, that's 80. So that's 8, by the way. So then you take x out, you get 4 plus pi. And when you substitute x in, don't forget that it's maximum x equal to 40 on 4 plus pi. So when you go to 40 on 4 plus pi all over 8, and then 80 minus 40 over 4 plus pi times 4 plus pi. They're very nicely. Thank you very much. The 4 plus pi cancel. 40 divided by 80 is 5 on 4 plus 5. And then you got 80 minus 40. And that means it's going to be 5 on 4 plus pi. And then it's going to be 40. So the answer is 200 on 4 plus pi meters squared. And that is your maximum area. And that's your maximum area, which is answering the question. All right. And that's where I'll stop.